So testing a coil, visually check the wire for deterioration. So if there's pitting, corrosion, anything like that, it won't work properly. Test the system power on and off, disconnect, or turn the system power on off. Turn the system power off and then disconnect one lead to the coil. No, we don't do this. And then connect 1 meter lead to the end of the coil. A null or a low reading indicates continuity. You need a special way to connect to it because they're coated on the outside and you have to touch it just right. Again, you're never going to do this. So connect 1 meter lead to each end of the coil. A null or low reading indicates continuity. So that means good flow of electricity through the coil. A reading of high or infinite resistance indicates the coil should be replaced because it's broken somewhere on the inside. Electrostatic discharge. The human body can generate a tremendous amount of voltage called static electricity. Electrostatic discharge is a transfer of electrons from one object to another. Buildup of energy with nylon clothes can easily reach 21,000 volts. But very little current, right? Very little current, just enough to pop you. So about 750 volts can produce a visible spark and an audible spark. A mere 10 volts can ruin a computer chip. So you can see it doesn't need to be much. Again, these are older chips. The new ones are kind of protected against this a little bit today. External factors determine the amount of energy released. ESD damage. Components are becoming smaller and operate at lower voltages. The components are more susceptible to damage from ESD. ESD causes 3 categories of problems: catastrophic failure, frying or smoking of a part, upset failure, erratic fault in a component, and a latent failure, a weakened transistor. So they can become weakened because the lightning bolt that you just put in there essentially has ripped through some of that substrate and it's messed up the electron flow and paths and things like that. These things are very sensitive. But again, our gear is hardened towards this today. So we can thank the military for that. They've hardened our electronics and they're much, much better than they used to be. Preventing ESD. The leading cause of ESD damage is improper handling of electronic devices. We've talked about grounding yourself before you touch anything. The key to ESD prevention is to keep all electronic components and yourself at a common electrical potential. You don't want to have more charge than your components do. You don't want to have less charge than your components do, or they're going to bite you instead. Ground yourself by touching the metal computer chassis that's plugged into the wall. Otherwise, it does no good. Do not move around while installing or handling a part. Don't walk across the carpet, especially in winter if you're wearing a big fuzzy sweater. Use ESD suppression devices when working with exposed parts. Again, just touch something metal or strap yourself down. Anti-static devices. An anti-static mat, a non-conducting pad placed on the work surface, anti-static wristband, and a wristband with a grounding strap that connects the PC to the PC chassis. That keeps everything flowing as particles are generated. It keeps them all at the same level. So that's what they're getting at here. An anti-static pouch, a sealed non-conducting pouch used to store electronic devices. Anti-static pad, an insulating foam pad for individual chips with exposed pins. So what else can you use for this? Cardboard. Cardboard works great. And another thing is when you're building a bench in your house, and your wife's going to love this, or if I'm talking to the wife, you're going to hate this. You can build a wooden bench in your office and just work on a wood bench. Go have Home Depot rip a piece of plywood down the middle and build a 4-foot or 8-foot bench, whatever you want to build, right? So just wooden desktops are great, but you got to sand them down. They get nasty. So what I do is I always use a file on the edges and get them smoothed off so you don't rub your finger, get a splinter. And then I paint them like 5 or 6 times so the paint's really thick. And then those are awesome workbenches for computer stuff. And with that, coupled with cardboard. Electricity safety is your responsibility. Do not do any of the stuff that we've discussed in this video when it comes to the power supply stuff. Standard wall outlets in the United States provide 120 volts AC, but the amperage can be different. You can get 15, 20, 30, 40, 50, up to 50 amps, I believe, in standard outlets. And that's plenty to kill you. More people die from 120 volt shocks than do 220. Because I told you before that the higher the voltage, it just knocks your hand right off. But the 120 you're strong enough to hold on to, and you can't let go because the electricity is totally messing up all the nerves in your hand. You can't let go. So someone needs to kick you off of it, like run by and kick you off of it. Because if they grab you, then they're going to die also. So 120 volts is plenty to kill you, trust me. You can receive a lethal shock from much lower voltages than 120. We talked about on the phone line, those are 48 volts. That's enough to ruin your day right there, but it won't kill you. Inside a computer and a monitor, voltage as high as 30,000 volts can exist even after the power is turned off. Where is that power stored? Capacitors. Capacitors store those voltages. But they're very little current, but it's enough to stop your heart, which can kill you. So you don't die from the electrical shock, but you die because your heart stopped if it hits you in the wrong place. Don't mess around with this stuff, please.